So I found this interesting video short on YouTube. And so the author was doing this 35 times 75. And then he just basically did 5 times 5 is 25. He wrote that down. He did 3 times 7 is 21. And then he took the seven, that result, 21, added it to the 5 and got 26. And so a person might actually say, well, think that this is a general idea, but that works for every number ending in two-digit number ending in 5. And so the YouTuber should have explained this because this doesn't work at all times, right? So this is a problem with overgeneralizing. So here is the distributive property explaining what's happening and why it works. 35 times 75, as you can see here, we end up with 50 tens, right? For the terms, we end up for the 3 terms, we end up with 4 terms, we end up with 15 tens and 35 tens. What does this mean and how does it work? Well, this system can work provided that when you look at these two-digit numbers, what you can notice is that if they are complements of each other when you try to make a sum of 10, then it would work. So it would work with 25 times 85. It would work with, it should work with 15 times 95. So these first digit, the digits in the 10th place have to be 10 complements. I mean, complements of each other to make 10, all right, in making up 10. And so here is the proof of why it works, all right? So you can pause the video and you can look at that yourself. So again, this works for numbers like, again, you can do like 15 times 95, 25 times 85, 35 times 75, 45 times 65, and so on. All right. 55 times 55 might be a unique case. Let me see if that works out. 50 times 55 times 55. Did I do that? 55 times 55. 55 times 55. Does it work? Yes, it works also. So as long as the m and n are complements of each other, right? To make 10, all right? So that's it. All right.